Hello and welcome to session 7 on disaccharides. So a disaccharide forms by reaction of the OH group, uh, OH group of OH group on the anomeric carbon of one monosaccharide with another uh, with the OH group of a second monosaccharide. So the linkage formed is called as a glycosidic linkage and is named according to the number of the carbon at which the linkage begins and the carbon on the second monosaccharide at which the linkage ends. So we have seen uh, we have already seen the anomeric forms of sugars. The glycosidic linkage is also designated as alpha or beta depending upon whether the conformation at the anomeric carbon is up, is down. It can be HCOH or OHCH. So this is the basis for naming of the glycosidic linkage. So disaccharides contain an glycosidic linkage or a glycosidic bond. So this is an example of the formation of maltose. Maltose has two monomers like alpha D glucose and beta D glucose, and these two sugar units they undergo condensation to form a glycosidic linkage. And the linkage, if we look at the position how the numbering is being done, see, please focus on this number. The linkage is 1 4 linkage. So this is your 1 and this is your fourth position. So the linkage is formed between the 1 of alpha D glucopyranosol and fourth carbon of D glucopyranose. So hence the linkage is formed between the 1 and 4. We call it as a 1,4 glycosidic linkage. So this is the meaning of 1,4 glycosidic linkage. Now together it is a dimer. So here we have one monomer and this is one monomer. All together it forms a dimer after going condensation, and where the linking bond is formed, the glycosidic bond is formed between 1 and 4. And this is the structure of sucrose. So in sucrose, again we have two monomers and the linkage is 1,2 linkage. So this is one sugar, I'm sorry, yeah, this is one monomer and this is another monomer, and these two monomers, they are linked by 1,2 linkage. So this is your 1 and this is your 2, 1 alpha 1,2 linkage. And in case of maltose we have already discussed. So it is a 1,4 glycosidic linkage, and this one is the lactose. So and in lactose the linkage is beta. It's not alpha linkage, rather it is beta linkage. Yeah, in lactose it is beta 1,4 linkage. This is your 1 and this is your 4, and this is the glycosidic bond. So this is the glycosidic bond formed between galactose and glucose. Galactose and glucose, because here it is beta D glucose, it is not alpha, so hence we are having beta 1,4 glycosidic linkage. So lactose, which is a milk sugar, it is present in milk, it is a disaccharide. It has formed by the condensation of the two monomers beta D glucose and beta D galactose and beta D glucose. So again reducing versus non-reducing. So disaccharides with alpha 1,4 and beta 1,4 and alpha 1 alpha and 2 beta glycosidic bonds that yield disaccharides are maltose, lactose and sucrose respectively. Both alpha 1,4 and beta 1,4 glycosidic bonds leave one acetal or hemiketal free, and these ends will show a positive behavior for Benedict's test example maltose and lactose. The fructose having alpha 1 alpha 2 beta glycosidic bond have protected hemiacetal and ketyl groups which were unable to undergo individual conversion or reaction with Benedict's reagent. Therefore, sucrose is considered as a non-reducing sugar. So, your maltose and lactose both are reducing sugars, but sucrose is a non-reducing sugars. Sucrose and trehalose are both non-reducing sugars because the anomeric carbon of both monosaccharides in these compounds are tied up. They are not free, tied up in the glycosidic linkage, and it is not free to react with the Benedict reagent. Okay, with this we'll stop on disaccharides. In the next lecture we'll discuss about polysaccharides. Thank you. Thank you, one and all.